Well, hello and welcome back to McClutchy Maths. My name is Natalie McClutchy and we are continuing our video series here today on index laws, and we are looking at something called the zero index law. Let's get right into it. This is what our law looks like. You'll be familiar by now that we've got these laws with letters and powers, and then we unpack them with some numbers. That's what we're going to do today. So it starts with a to the power of 0 is equal to 1, where a is not equal to 0. Now that might sound very, very confusing. What that's basically saying is any number or letter, when it has a power of 0, the answer will always be very simple, just the number 1. The only time it doesn't work is if this number here is a 0 being raised to the power of 0. We're going to talk about that later on. What does that mean when you have a 0 raised to the power of 0? So first of all, let's think back to index law 2. That was 2 videos ago. And you might remember it looks like this. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. Now let's see what happens when m is equal to n. Okay, so when these two numbers are the same. So that might be a 10 and that might be a 10. Let's see what happens when that happens. Okay, so let's think about using some real numbers. 3 to the power of 3, and we're going to divide that by itself, 3 to the power of 3, because that's what happens if those powers are the same and the base is the same. We're dividing the number by itself. So another way I could express that would be 3 times 3 times 3 divided by 3 times 3 times 3. You'd recall anything divided by itself is going to be equal to 1. So that means we're going to cancel out 3 divided by 3, which makes 1, divided by 3 again, makes 1, makes 1. So you might be wondering, does it all just become 0? No, it doesn't, because anything divided by itself is equal to 1. So what I've got now is 1 times 1 times 1, which makes, you guessed it, 1, which is why our rule works. Anything divided by itself equals 1. So the minute we have the same base and our two powers subtract to make 0, means these two numbers have got to be the same number. So we've basically got the same number divided by itself. Now you'll notice the law only works when a is not equal to 0. And the reason for that is that because anything divided by 0 is undefined on your calculator. You can try that yourself if you like. You can go and do 12 divided by 0. You're going to get an answer like a syntax error or something like that. It's impossible to divide something by 0. So the reason why it works is if my base was 0 and then I tried to do that to the power of 0, well, what I'm saying is 0 divided by 0, and like I said, anything divided by 0 is equal to an undefined answer. So that's why that happens. Okay, let's do some examples and see how this works. Okay, so our first example is the number 5 to the power of 0. Okay, so you remember our rule, a to the power of 0 equals 1. So therefore, 5 to the power of 0 equals 1. Let's try another one. In brackets, so remember our brackets rule, everything inside the brackets gets the power outside the brackets. So everything in the brackets is getting this power of 0. So the negative 2 gets a power of 0, h gets a power of 0, which means everything in the brackets just becomes the number 1. In fact, 1 billion to the power of 0 is going to be equal to 1. Negative 1 million to the power of 0 is going to equal 1. Anything to the power of 0. Letters, numbers, it's going to be 1. Okay, now this is my third worked example. You can see here that in this case it's a little bit different. I've got a 6 out the front. It's 6 multiplied by f to the power of 0. Only the f has the power of 0. This is where you've got to be really careful, because it seems like anytime you see a 0 as a power, right, I'm just going to write that number 1. Not always, because in this case 6 is not raised to the power of 0, only f is. 6 is raised to the power of 1, and we just don't write that 1 down. There's also an invisible times in between the two of them. So what we've really got is 6 multiplied by f to the power of 0, which equals 6 times 1, which is just 6. Okay, so in this case, the answer is not just 1 every single time. This part becomes 1, but it's now multiplied by something else. So you've got to be careful. Okay, so we've got one of these examples again, trying to trick you. So we've got 2 multiplied by y to the power of 0 plus everything in brackets for y to the power of 0. So we've got the law being applied in 2 different ways here. So first of all, let's look at this first part here, 2y to the power of 0. 2 is not raised to the power of 0. So 2 will be multiplied by 1 in this case. And over here, everything in the brackets is raised to the power of 0. So that whole part of this expression will be the number 1. So now I've got 2 times 1 plus 1. Well, 2 times 1 makes 2. 2 plus 1 makes 3. So it might be very tempting to look at this question and think, right, it looks like the answer is going to just be 2 because I'm going to make the first one a 1 and the second one will be a 1. No, you've got to be really careful and inspect these very carefully. Well, that's all we've got time for. It was a quick, short, sharp video. Hope you found it helpful. You can engage further with the channel by liking and subscribing, hitting that notifications bell, and following us on social media, Facebook and Instagram. And if you found it helpful, why not tell us in the comments? I always love hearing from you. And if you've got any questions at all, you can contact me at mcclutchymass@yahoo.com. Do stay tuned for our upcoming videos. We're going to get into some more complicated index laws very soon, like index laws that are negative, index laws that are fractions, and we're going to look at some combinations ones as well. Thank you so much for watching. Have a wonderful day.